right, it's 2 minutes after 3:30. I think we can start. Good afternoon, everybody, or good morning, depending on where you are. My name is Tandi Kapwata. I'm here on behalf of Kara D. Wright. She's unable to introduce our speaker for today. She's traveling. So today I have the pleasure of introducing Professor Noah Skovornik, and he will be giving us a presentation today. Noah is a Rollins Distinguished Associate Professor at Emory University, Rollins School of Public Health in Atlanta. Dr. Skrovernik's research is around climate and health. He's also the Deputy Director of Emory's federally funded Climate and Health Actionable Research and Translation Center. Noah, over to you, please.
Thank you, Tandi. Are you able to hear me still?
Yes, clearly.
Okay, and let me share. And are you seeing my slides as well?
Yes, we can. Thank you.
Okay, great. And then the last question I have before I get started, do you normally, should I take questions as I go, or should we wait until the end?
We normally wait until the end, but do you prefer to
Okay.
take them as you go?
Either way, it's fine. We'll do
We'll
that. We'll
just
wait
wait
till the
until
end.
the end.
All right,
Okay.
thanks. So, good afternoon, everyone. Obviously, it's morning here. Before I get going, I just want to thank the organizers for inviting me. I don't know most of you, I know a few of you, but I did get an opportunity to spend a number of years in South Africa, and including a master's at UCT and a short postdoc at WITS. So the country is very close to my heart, and I'm pleased to be able to speak with you all, and very impressed and excited to hear about everything you all do around climate and health there. So I guess the only other thing I'll say on that is that maybe we can organize something in person in the future, because I would love to be there with you all and be able to do this not across an ocean. But leaving that all aside, I'm going to talk a little bit today, or I guess I'm going to talk a lot today about essentially the idea of health co-benefits. So in other words, the air pollution benefits that we can get from reducing greenhouse gas emissions, and how that might inform different ideas about which countries should be reducing their emissions relative to other countries. But I do want to just talk a little bit of an introduction before I get into that, just about the different types of work I'm involved in related to climate and health, because I know this is a pretty diverse group in the sense of what you're all working on, and perhaps it will make the discussion more interesting at the end, and also maybe there'll be some opportunity for collaboration. So just want to go through the three different types of sort of research strands that I'm involved in quickly, and then I'll get specifically into this new study that I'm going to be presenting today. So the first strand of my work is really about sort of your straightforward epidemiological studies. So my focus here is on climate-sensitive health risks, climate-sensitive exposures. Heat is probably my main interest. I do some work on air pollution, and increasingly on pollen. If any of you have been to Atlanta, we have a lot of enormous trees and an extremely, what's the word I'm looking for? Robust pollen season that starts in February and ends in about November, so almost the whole year. And we're doing a lot of work trying to understand more on the health burdens around pollen, which I know is also an issue in some South African cities, and that there's been, at least I'd heard, there was some efforts to start collecting pollen data there. So perhaps that's an avenue for collaboration in the future. But most of what I work on at the moment is related to epi studies in the US, particularly trying to understand links between these climate-sensitive health risks and hospital visits. So we mostly are using a multi-state hospital data set for that, but increasingly we're also looking at electronic medical records, which sort of has the downside of, you usually get only a few hospitals, so you lose some statistical power. But the upside is that you have a lot of detailed information on each patient. So things like medications they're using, comorbidities, lab results, vital signs, and that sort of thing. So we're trying to think about how that richness in an electronic medical record can help us understand who's most at risk for heat and air pollution and pollen, but also how do we intervene to try and protect those folks. So that's sort of on the US side. I do want to mention that I'm also sort of less than before, but still involved in quite a bit of work using South African data. I was able to get some South African data when I was living there, and we've done a lot of work on heat, sort of in two forms. One has been related to specifically understanding heat risk in South Africa. So these single country studies, sort of thinking about different subgroups and different causes, but also some work with Tandy, for example, on trying to think about whether we can use those associations to start to inform warning systems related to heat. And then the other side is really involvement in the multi-city, multi-country collaboration. These are just some examples. There's no need to look at them in any detail. I'm not going to talk about these papers. But the multi-country, multi-city collaboration really looks at or thinks about how we can try to learn more about weather health relationships or air pollution health relationships using data from multiple places which have diverse climates, diverse populations, and that sort of thing. So that's really the epidemiological side of what I work on. The second thing I want to mention, which is the newest for me, and something I never thought I'd get involved in, is around hazardous substances. So really thinking about chemical exposure. So chemicals that were spilled or dumped in the environment, often decades ago, and persist. This is a project that I thought was going to be about heat, but when we talked to some of our local partners in coastal Georgia, the primary concern was around exposure to these chemicals. But we do think it's going to be connected to climate change in the future, which I'll talk about in a moment. But essentially, this work concentrates on a city called Brunswick, which I doubt anyone there would ever have heard of because I had never heard of it even after living in Atlanta for a couple of years. But it's about 4 hours southeast of here on the Atlantic. You can see this map. It sits in this really complex ecosystem of marshes and rivers next to the ocean. And what you're seeing in the yellow is these hazardous sites. So there are 4, one up here, one down on this Turtle River, another one here, and then this one's sitting on the marsh. And these are federally listed hazardous sites. This is the only city in the state that has 4 of them. And the reason why we're also thinking about human exposure in the context of climate change is that you see this map. This is a map of today, essentially. And this is a map of what we are expecting given just 1 foot or about 30 centimeters of sea level rise. So you can see that some of these hazardous sites where the contamination is present will be almost completely inundated in the future. And that could be sort of changing exposure patterns and also could compromise some of the remediation efforts that are going on in Brunswick. So that's a second strand of the research I'm involved in. Again, nothing I expected to be doing, but it sort of fell in my lap, so to speak, and it's really been a super rich and rewarding project, but with a steep learning curve. And then the last thing, which I'm going to talk about today, is this idea of health co-benefits. So I think many of you, since this is the climate and health seminar, will be familiar with this concept, but this is really the idea that if you reduce emissions, if you mitigate for climate purposes, you not only get the climate benefits, but you can get these side co-benefits that can be very important for public health, but are not necessarily directly related to the climate benefit. So there are examples of this in many sectors, like eating plant-based diets, for instance, healthy plant-based diets, or walking and biking more in the transportation sector. But the most direct example of this is through air pollution, and that's what I'm going to be discussing in the talk now. And really the idea here is very simple. So if you burn fossil fuels in a car or in a power plant or for industry or whatever it may be, you get your carbon emissions and you get your air pollution emissions. And therefore, if you enact a policy to reduce your fossil fuel use, you get the carbon benefit, the climate benefit, and then you also get this health co-benefit because of improved air quality. And of course, air pollution is responsible for many millions of premature deaths every year. So these health co-benefits can be very large, and they can, as I'll talk about in a few minutes, accrue, particularly in places that already have pretty bad air pollution. So that's the background of what I work on. And now I want to get specifically into this new paper that we're involved in and the results there. And then hopefully we'll have a discussion around that at the end. Just by way of background on this specific paper, this is a paper that is currently in review as part of a Lancet series on energy and health. So if you're interested, I put the preprint up here with the abstract number. You can just put the abstract number and SSRN into Google and you could find it. And essentially there was a Lancet series on energy and health about 15 years ago. And the idea here is to sort of update that series with all the knowledge, or obviously not all of it, but the key points, the key learning insights in the literature over the last 10 or 15 years, and also to make sure that there's an emphasis on low and middle income countries, because I think that was not necessarily treated as well as it should have been in the last series. And essentially, when the leads of the new series approached me, they wanted to do a paper on the links between climate and energy, and specifically this idea of health co-benefits. So assuming all goes well, this series will be out at the end of the year, I think. And there'll be something like 5 papers on different topics related to energy and health. One on electricity. I think there'll be one on the healthcare sector. There'll be an overall paper. There'll be this one and 1 or 2 more. So you can see the author list here. It's a pretty big group, but we have not yet received the reviews. So this is actually the first time I'm presenting it. So I thought this would be a good group to talk about this with. So I'm really excited to talk about it with you. I also was hoping that maybe it's different from what you've seen in prior seminars, but I guess I don't really know what the other speakers have talked about. But I think this will be hopefully interesting. And just to say again, we're really straddling, in some sense, the line between a review article and primary modeling. So everything that I'm going to present to you is new research, but we were picking up on a lot of the insights from the literature over the last 15 years or so, and trying to make them a little bit more explicit, where in some cases they were sort of implicit in some of the landmark papers prior to this. So just to expand on that a little bit, we really were drawing from 4 different literatures, broadly speaking. One is on global energy systems, so really understanding a little better, sort of, I guess the modeling represents global energy systems better and better every year in terms of which technologies are being used, emissions inventories, and also for the purposes of this talk, the costs that are associated with reducing emissions. So that's the first one. The second one is about air pollution risks. So really thinking about just what we've learned from exposure response functions and that sort of thing over the last number of years. The third is improved understanding of climate harm. So obviously the main reason to implement a carbon policy, a carbon reduction policy, is for the climate benefits. So you shouldn't ignore those in an analysis of co-benefits, because that's still the important and the primary rationale for implementing these policies. And also because, as I'll show as we go along, the climate benefits can be the dominant type of benefits, at least in some countries. And then finally, there's been a bunch of work over the years on economic evaluation related to climate change. So clearly, climate presents a bunch of unique problems for probably all fields, but economic evaluation as well, because we're not only thinking about costs and benefits within one country over the time of like an infrastructure project. We're talking about costs and benefits across all countries, which are very heterogeneous in their populations, in their geographies, in their income, and so on, and difference and impacts, costs and benefits over long, very long time horizons. 10 years is not enough. We're talking decades, really centuries. So that's how we've sort of tried to focus our idea of what we need to include in a good health co-benefits analysis. And the reason for that is because there really are all these different types of important costs and benefits when you implement a carbon policy, a mitigation policy. You have to pay for that policy. You have to pay for the actions to reduce your emissions. Then you have the benefits from climate change itself, and you have these other types of benefits, these co-benefits, including the focus here on air pollution. And what we want to do is we want to use, sort of be able to integrate those different types of impacts in a way that lets us learn something about how to share the burden of mitigation across countries. So clearly, there are many different ways that different countries could decide to mitigate, like how much they mitigate. For example, some may want to do a lot, some may not want to do a lot. And this study is really about thinking, how should we distribute the mitigation burden across countries if we were thinking like kind of a global decision maker, but also how should individual countries be thinking about their own investments in mitigation. So again, that's the general background. And this author list is so big because we do have sort of teams from many different disciplines. There's a bunch of emissions modelers, air quality modelers, climate impact modelers, and the economic evaluation team. All right, so now I am going to start talking specifically about the study and showing some key results, and hopefully I'm able to explain them in a way that makes sense. And I have one method slide, which you're looking at now. This is the only method slide in the whole paper, not the whole paper, in the whole presentation, but I think it's enough to give a background on sort of the context of what we're trying to do. I'm not going to talk about any of the specific models. I can try to do that in the Q&A if people have questions, but I just want to give you an idea of sort of the steps and the thought process in terms of how these types of studies progress. So the first step is just to design some scenarios about what countries might do in terms of mitigation in the future. And then you have an emission modeling step where you use a model to actually sort of implement the policy in terms of not only the emissions, both carbon emissions and air pollutant emissions under the different scenarios, but also the costs associated with any emission reductions that are assumed to occur in those scenarios. And then the emissions sort of feed into two parallel models. One is the GEOSChem air quality model, which estimates the particulate matter concentrations associated with those emissions scenarios, which you can then use to estimate the health impacts. And then those emissions also go into I guess I'm calling it a climate impact model, which tells you estimates the climate harms for every country based on that level of emissions. So it counts for, I guess one way to think about it, maybe this is an oversimplification, is the air pollutant emission results go into the air quality model, and the greenhouse gas emission results go into the climate impact model to give you an estimate of climate harms. Or I think a better way to think about it will be avoided climate harms. And then once you have those different elements, the costs of your scenarios, the climate benefits of the scenarios, and the health benefits of the scenarios, you can use that economic framework I alluded to sort of add everything up and give you hopefully some insight into which scenario is better than the other scenarios, both globally and country by country. So that's the general flow of what I'm going to be talking about for the next 15 minutes or so. All right. So essentially, we have three core scenarios in this work. We played around with many more scenarios, but I think these three really capture the salient features of the scenarios that we wanted to look at. And obviously, the more scenarios you have, the more complex it is to present. But we have what I'm going to call the reference scenario, which is your standard sort of business as usual scenario where countries don't implement any explicit carbon mitigation policies. So you might get some changes in carbon emissions over time for reasons independent of climate policy, like because of socioeconomic development or something. But essentially, you can think about the reference scenario as unabated carbon emissions. So fossil fuels continue to be used at pretty high levels. Then we have what's called, or what I'll call an efficiency scenario. So here the world achieves 2 degrees, so it keeps warming to 2 degrees through a global least cost approach. So this is sort of implemented as a single global carbon price everywhere in the world. This is pretty standard in the health co-benefits world. So the model essentially finds the cheapest way of achieving your emissions target. So here it's an emissions target that keeps the world to 2 degrees. And the way to think about it, I think for the purposes of this presentation, is that there's no constraint on where the mitigation happens. It happens wherever it's cheapest. So basically every country is under the same carbon price, and therefore there's a lot of mitigation everywhere in some sense. And then the third scenario, which I'm going to call an equity scenario, it achieves 2 degrees in exactly the same, globally, exactly the same way as the efficiency scenario. So the total carbon trajectory is identical, but high-income countries do a lot more of the mitigation than low-income countries. So this sort of connects to the idea of capacity that's in the UN Framework Convention on Climate Change. So here we sort of set it up as carbon prices in each country are proportional to their income. So very, very rich countries have very high carbon prices and therefore mitigate a lot. Low-income countries have much lower carbon prices and don't do much mitigation. But ultimately, the 2-degree target is still met. So I just want to say a couple things about these scenarios. We're calling that last one an equity scenario. It doesn't capture all elements of equity as it relates to climate justice. It clearly does not capture perfectly issues of like historical responsibility for climate change. It doesn't capture climate vulnerability directly, but what we found when we looked at the modeling, like what the outcome would be, is that because current capacity is so linked to historical responsibility and climate vulnerability that those scenarios would actually look very similar to this scenario. So we figured that this one should capture the key dimensions of what an equity-based scenario might look like. So these are the three I'm going to talk about for the next while. There are two other scenarios I'll mention very briefly at the end, but for our purposes, these are the three as I show these slides. And I'll try to continue to sort of explain in sufficient detail to give the key insights of what we're looking at, because I know for a lot of people, including myself, it's easy to get kind of confused in your head about the different scenarios and what they mean for different countries. But I think this figure will provide some of the key insights on that. So in this figure, you have the emissions, total emissions on the left, and per capita emissions on the right. And you see that in 2020, there's about 41 gigatons of carbon dioxide emitted globally. In the reference case with no climate policies, that rises all the way up to 55. And then in the 2-degree scenarios, in both the efficiency and the equity scenario, they both are limited to 18 gigatons in 2050, but the distribution is very different. So in the efficiency scenario, high-income countries are emitting a much larger fraction of the world's carbon than in the equity scenario, where high-income countries are actually net negative. And then you can see it again on the right here with per capita emissions. And I think the key thing to look at is in blue, these are high-income countries. In the efficiency scenario, they still emit the most carbon per capita, whereas in the equity scenario, they emit the least carbon per capita, whereas all the other income groups emit more carbon in the equity compared to the efficiency scenario. So again, in the equity scenario, high-income countries are doing more of the mitigation, so they're emitting less, whereas low and middle income countries are doing less of the mitigation, so they're emitting more carbon. Right. So what does that mean for air quality? And that's the purpose of this plot. And this really does reflect in a lot of ways the emissions plot I just showed, because obviously air quality is not exclusively a function of emissions. It accounts for meteorology and so on. But emissions, it still mirrors that plot in a lot of ways. So the top, you just have total PM concentrations in 2050 in the reference case, and you see still some very, very high levels, particularly around parts of Africa and South Asia. Whereas when you look at the efficiency scenario in the purple plot, this is really the reduction, the change in PM 2.5 concentrations compared to the reference, you see very, very large reductions in concentrations, reductions on the order of, if I remember right, like 15 or 16 micrograms per meter cubed lower in India, for example, in the reference case compared to, in the efficiency case compared to the reference case. And then this last plot compares equity to efficiency, and you see in high-income countries, in the equity case, they tend to have lower levels of air pollution because they're doing more of the mitigation, where the low and middle income countries, which are doing less of the mitigation, have somewhat higher air pollution compared to the efficiency case. And this is really reflected again in how much sort of the percentage of the population that meets World Health Organization air quality guidelines. So in the reference case, many fewer people hit the different sort of landmarks of the World Health Organization air quality guidelines compared to the two 2-degree cases where you're doing a lot of mitigation and therefore air quality improves substantially. So I know it's still, or I don't know if this is, but it may still be a little bit hard to wrap your head around. So I think this table really highlights the general idea here, which is that there's a big disparity in air pollution exposure between high-income countries and low and middle-income countries. In 2020, that disparity is something like 15 micrograms per meter cubed. This is weighted, population-weighted PM 2.5. In the reference case in 2050, the disparity actually goes up. It widens in 2050 under the reference case, and it's completely the opposite in the 2-degree cases. So in the 2050 cases, In the efficiency case, it's down to about 12 micrograms per meter cubed. It's a little higher in the equity case, but still lower than in the reference case and lower than what it is essentially today. So that's the story in terms of air pollution exposure. And then we have the health benefits. That's the next step in this sort of chain. And what we find, this is cumulative avoided deaths between 2020 and 2050 in the two scenarios. In both scenarios, compared to the reference case, you get enormous reductions in air quality related premature mortality. So something like 13.5 million deaths in the equity case, and almost, I think, about 17.5 million in the efficiency case. So you get very large health co-benefits in either of the 2-degree scenarios. But in the equity scenario, there's something like 4 million potentially avoided premature deaths that are left on the table, so to speak, all of which would occur in the low and middle income countries. And then this is just a rate on the right, which I don't think I need to describe, but essentially the takeaway here is that in the equity case, low and middle income countries are shouldering less of the burden of mitigation, but they are also therefore not gaining all the health co-benefits that might be possible in a case like the efficiency case. And that trade-off, I think, is a key maybe insight of the paper, and it's really shown here explicitly. I'm going to go through this in some detail. I'm going to start with these high-income countries. So here in the upper left, we have high-income countries, and this is illustrating the trade-off between mitigation costs and co-benefits. So here we're looking at the change in costs on the y-axis and the change in avoided death rate on the x-axis when you move from the efficiency case to the equity case. And what you see in basically every high-income country is that when you move from the efficiency to the equity case, the costs go way up because they're expected to shoulder more of the burden, but their health benefits also go up as we move this way. Now, some go up more than others. In some places like Norway and Australia, where the air is already very clean, they pay a lot to reduce carbon, but they don't get the same level of health benefits. And it's a little bit different for some other countries. And the opposite is true in the low-income countries, where when you switch from efficiency to equity, your costs, this is Uganda, for example, your costs go way down, but your health benefits are also reduced, essentially. And it's mostly the same for the middle income countries, though for the upper middle income countries, where South Africa is, that you get a little more variety for a couple reasons. One is some countries in that group, like China, are actually rich enough, so they do a little bit more in the equity case than the efficiency case. And then there are some other sort of outliers, let's call them, like Mexico, where even though they're doing less mitigation, they get more health co-benefits. But that's because Mexico is right next to the US. And if in this case, the US is doing so much of the mitigation and their air is getting clean, that there's like a transboundary benefit to Mexico, essentially. So this is just highlighting, again, this trade-off between mitigation costs on the one hand and health co-benefits on the other. And then we did calculate like the percentage of mitigation costs that could be offset by health benefits, which I don't really want to spend a lot of time on. We can come back to this in the discussion, but essentially you'll see in some places, particularly South Asia, for example, the health benefits are so large that if you monetize everything, they actually are larger than the costs of the climate policies themselves. So that's really the story of the air pollution side, but you'll remember there's also this climate impact side, which I want to talk about. And that's really what this plot is about. So this plot shows that it shows the different costs and benefits of the modeling for the different country income groupings, Below the zero line is a cost. So you have the mitigation costs are obviously all negative. And then the purple above the line are the climate benefits compared to the reference case. And then in blue, the air benefits. And what you'll notice is that in low income countries, the climate benefits are just enormous. So even without the air quality benefits, the climate benefits far outweigh the mitigation costs. That's also true in lower middle income countries, though not to the same extent. But here and in the upper middle income countries, the air quality benefits are really important in terms of making that benefit cost ratio very favorable. So the mitigation means that the benefit cost ratio in all of the three low and middle income country groupings are beneficial in the sense that the climate benefits plus the air quality benefits outweigh the mitigation costs. But it sort of goes down as you increase in income to some extent. So again, what it's saying here is that's very good for most countries of the world and most people of the world to implement some sort of climate policy, some sort of 2-degree policy compared to a reference case where we let emissions go unabated because you get these large climate benefits and you get these large health co-benefits. But where the two matter most depends somewhat on which country grouping you're talking about. All right, so now we're getting to the meat of the problem. This is the final slide before I summarize and then have one more slide. So really the question here is, which is better? Is the equity case better or is the efficiency case better? So globally, what we found using these economic methods that really do account for inequalities across countries. So it really accounts for the idea, for instance, that $100 of climate damage in the US is worth less, or it means less than $100 of climate damage in South Africa or Venezuela or something like that. So it accounts for that sort of the well-being aspect of a dollar, essentially. And what we found to our surprise is that globally, if we're thinking about this from a global perspective, the two scenarios are actually pretty similar. And that's because there's only a difference of a couple percent in like net present value. And that's because in the lower and middle income countries, they're paying less, but they're getting less of the benefit. Whereas high income countries, they're paying a lot more. And there's some burden to the people, the residents of those countries. So when you put it all together, it actually means that the efficiency and the equity scenario are more similar, though the equity scenario still wins out by a little bit. And then you can look at it country by country. And here, here you do see a pretty big difference where almost all low and middle income countries, if in blue, anything in blue essentially means that you prefer the equity case, and everything in red means you prefer the efficiency case. So almost all low and middle income countries, sort of thinking of it, this is not quite the right analogy, but in a self-interested way, should prefer an equity type scenario. High income countries prefer an efficiency type scenario. But there are some exceptions, like India and other parts of Southern Asia actually prefer the efficiency case because of those huge health co-benefits that they can achieve by doing more mitigation. And even several other countries, although they do prefer the equity case, these are like in the light blue, it's not by a lot. So it's not like the equity part of it doesn't swamp the other part of it. So there is some heterogeneity across countries, but not to the, it's not as extreme a difference between the two scenarios as we expected because of this trade-off. Okay, I'm going to summarize, then show one more quick slide, and then finish it off. So I know I threw a lot at you, but just want to summarize quickly. So the health co-benefits of limiting future warming are likely to be large. This is not something that's new from our study. Many other studies have found this. We found this as well. And similarly, the majority of those benefits will occur in low and middle income countries where there are more people and where the air quality on average is substantially worse. But there is this trade-off between mitigation costs and co-benefits. Fourth, when you add the climate benefits and the co-benefits together, the total benefits far outweigh the mitigation costs, particularly in low and middle income countries and particularly in low income countries. And globally, again, if we think about this globally, a scenario where the mitigation burden is shared, as in the efficiency scenario, may be surprisingly similar from a total global well-being perspective to the equity scenario. But with some exceptions like India, most low and middle income countries should still prefer an equity type scenario. And finally, for basically all countries, either of the 2-degree scenarios is better than a reference scenario where we don't reduce our carbon emissions. Okay, so the last slide, I don't really think that you even need to pay attention to the actual figure, but there are a couple scenarios that some of you may be thinking could outperform either of the scenarios that I've talked about. And if these are the same ones I'm thinking about, you're correct. And I'll describe each one quickly, and then I'll wrap up for questions. The first scenario is a scenario where it's like the equity scenario. So low and middle income countries shoulder less of the burden of mitigation, but they use the cost savings to invest in end of pipe air pollution technologies to get the health co-benefits they would have gotten in the efficiency scenario. And because end of pipe air quality measures are cheaper usually than cleaning up your air with carbon policy, you can actually get the same level of air quality benefits at a lower cost. And that's really what this is just showing, is basically there are cost savings to do an equity for low and middle income countries to do an equity-based scenario in terms of carbon, but to still implement air quality solutions domestically, which kind of more than pay for themselves from the savings you have in the equity scenario versus the efficiency scenario. And then the last one I want to talk about, which we didn't model at all, is obviously a scenario where rich countries just send cash transfers to low and middle income countries to do mitigation would perform the best in this case, because the low and middle income countries would be gaining all of the climate and all of the health benefits that they would have, but there's no cost to it, essentially. So just to put this final summary point, there are other types of scenarios beyond the efficiency and equity type scenarios that could outperform those scenarios. Whether they're realistic, is a question beyond me, but they do exist. So with that, I am going to stop. Thanks for listening. I hope I haven't thrown too much out, and happy to take questions. And I've not been monitoring the chat, so if there are questions there, let me know.
Thank you so much, Noah. That was amazing. I will just open the floor for questions from the floor. Do we have any questions, Amy?
No questions so far, Tandy.
Shall I open it up? Any hands? If you have a question for Noah, you can just please raise your hand. Okay, so while we wait for that, so I'm not sure I understood everything, but I think I did. It was it was
I know it was a
very
lot. I took a
interesting.
risk
Yeah.
deciding to present this, but I really wanted to do it because I haven't done it before. So I appreciate
Yeah,
everyone bearing with me.
it was really interesting. So the question I have is around, so from all the slides you were showing, right, it looks like the efficiency scenario has the most health benefits,
That's
right?
right.
So I'm just thinking then the other slide you presented, you clearly showed that there are disparities in air quality exposure. So if we're saying that there are these large disparities, but then we also know that what has the most efficiencies for health, what has the most impact on health is the efficiency scenario. How do we then frame this to lower middle income countries to say that, taking into account all the aspects of climate justice and all of those things, the efficiency scenario has the most benefits for health?
Yeah, I mean, I think that that's exactly, you've just summarized better than I did the core question here, which is, or maybe the core feature, which is that the health co-benefits of reducing your carbon emissions can be so transformative from an environmental health perspective that some countries would miss out on that if they were to argue exclusively for a very climate justice-based policy where they're not expected to do much in terms of mitigation. And that's really, this table really makes that clear, where air pollution is just so much higher in parts of the world that don't have a lot of historical responsibility for climate change, for example, or don't have as much capacity to pay for mitigation. But because of these high levels of air pollutants, the efficiency scenario could either completely pay itself back or at least pay a lot of those mitigation costs back because your population's getting healthier and healthier. So, it's, I think, above my pay grade to say how countries should be thinking about their commitments to carbon reductions in the, in the world of global geopolitics. But I think the key thing is that, like, you really should be at least considering the health co-benefit angle, because it can be a really transformative mechanism to improve the health of your population. Now, the reason I threw in that what seemed like an afterthought at the end about countries cleaning up their air independently of carbon policies is that would be another way to think about it if you were sort of an average low or middle income country, where from a climate justice perspective, you still might want the richer countries to do most of the carbon emissions, but then you would want to still enact air pollution policies to get those health benefits for your residents, essentially. And that could be cheaper potentially than doing it through carbon policies, because you might be able to just put some technologies at the end of a power plant and get a lot of the benefits that you would have had to get by shutting off the power plant and turning on a solar panel plant or something like that.
Okay.
That was a really long answer, but you got at the core question here. Absolutely.
Thank you. And then just one more question from me. So I was just wondering if you looked at what sources would need to have the most reductions in carbon when you were looking at those different scenarios.
Yes. So I don't have that, but the model does, like the emission model does output like sector by sector changes in carbon emissions. So I could theoretically ask my colleagues who did the emission modeling for any country, like, how much would the reduction be in transportation and power plants, in industry or whatever it may be. When I was preparing last night, I was sort of hitting myself because I thought I really should have pulled all that information for South Africa for this presentation, but I didn't get to it, and
Would
I'm
have been
sorry
great
about
to
that.
see. No problem.
I
Would have been
can
really
pull it. If
interesting
anyone
to
wants
see.
to see it, just email me and I can pull it out. One of the benefits and weaknesses of these types of analyses is you get the global picture, but so much of the richness is lost country by country in terms of what's really happening on the ground.
Okay. I think I've hogged enough of the space. Are there any other questions? I think, well, what's left for me, Noah, is to thank you very much for this really insightful presentation. I think we all thoroughly enjoyed it, and I'm sure there'll be more questions to come via email. So please just
Absolutely.
look out for that.
Everyone should feel free to reach out anytime. And again, thanks for having me, and really great work you're all doing in South Africa. It's very, very cool to see.
Thank you so much, Noah. And
Have a
thank
good
you to
day.
everyone for attending.
Thank you.
Bye-bye.